Hello, this is the Kubernetes end-to-end series with Hilltop Consultancy. My name is Chafa Sani, and I'm going to be taking you on this course on how to create a Kubernetes cluster with the AWS Amazon EKS. So please follow along with me as we continue to create our Kubernetes cluster. The first thing you do is after you sign into your AWS Management Console, you would like to find a region, a suitable region where you're going to be deploying your resources. For this demo, I'm going to choose the US West 1 region just for demo purposes, but definitely within your company, you should have a designated region for this purpose. So I select my region, which is US East 1, California, and I go to the search tab. You can already have it here if it's a recently visited service, as well as you can have it here under EKS. The Kubernetes service, you can star it to make it a favorite tab. So when you open the EKS console, definitely this is 2025, February, and AWS has done a lot of updates on the EKS console. So you go to create a cluster. Now you will notice that something new has added. If you are an old user of Amazon, you will notice something new has added. Another way of creating the Kubernetes cluster, which is the auto mode. The auto mode simply summarizes a lot of configuration and creates the cluster in one go. But for comprehension purposes, we're going to use the custom configuration so that we go step by step to ease your understanding to know what is happening behind the scenes. Okay, so you go to custom configuration. Under custom configuration, you see it still proposes the auto mode. So you uncheck the auto mode since the auto mode simply automates the cluster creation process. So we uncheck the auto mode and it gives us full configuration power over the cluster. The first thing you want to do is to give your cluster a name. So for this lesson, we're going to use the EKS Hilltop Rock, assuming we're creating this for our production account. And then it tells you to create an IAM role. Select the cluster IAM role that allows the Kubernetes control plane to manage AWS services on your behalf. So if you have a role already existing, you can pick the role from here. But since for this demo, we will have to create a role. So you go to create recommended role. So you click on create recommended role. It takes you to a new tab, to the IAM section, and then you already see the rows at this point will be pre-selected rows. So the rows will be pre-selected rows. So AWS service and the use case is EKS and it's for an EKS cluster. So you go to next and you see the role EKS cluster policy is already created for you. So this is the name of the role. You can copy this and just hold, go to next, and then it gives you an option to put in the role name. So I'll rename this to role, Amazon EKS cluster role, and that is all. And then you click on create role. So remember the name we use, Amazon EKS cluster role. So back to this tab, you click on refresh here, and then you see the role auto populate here, Amazon EKS cluster role, the one we just created. It auto populates here, and we pick the role. It asks for the Kubernetes version. Now Kubernetes at this time of the recording is on version 3.2, which is the latest, but we're going to go with the standard with this version, 3.31. And it asks for upgrade policy. So we're going to go to the standard upgrade policy. The standard upgrade policy simply means when the version of Kubernetes expires and there is a newer version, you're going to pay a little more higher. So there's going to be, with the extended role, I'm sure you're going to pay a little more when support ends for this current role. So that's why we go with the standard. And for auto mode, remember we are already unchecked auto mode. So we don't want any resources or any nodes created for us. Now it asks for cluster access. Um, Do you want to access your Kubernetes API as the Kubernetes administrator, or developers want to access and deploy resources? You check this if you need that access. But if you want to disallow access to the cluster, you check this. So we definitely want to connect to our cluster. And as of now, there are two ways to connect with the cluster, either with the API or with the config maps. With the config map, it's a little complex and advanced, but we're going to see that later. So we are going to go with the Kubernetes EKS API to connect to our cluster. For now, we don't have any encryption. We're not using any KMS keys now to encrypt this cluster. And axonal shift, this we just leave as disabled. We don't need this now. For tags, we don't need any specific tags for this cluster. And it takes you to the VPC or the networking console. Now, you see in this region, we have a default VPC, which is a network configuration that comes with every region. And you have two subnets within this VPC, which are already pre-selected. So we are going to go with this. But definitely, if you're working in a company, you will definitely have your own customized VPC and subnets. You have the public subnet, the data subnets, and the private subnet. So we go with the default subnets for this demo purpose. And for security groups, it's optional. We don't have any additional security group to add. So it's going to create a default security group for this cluster. And what is your IP stack? We're definitely sticking with IPv4 stack. So we leave all other settings as default. Cluster endpoint access. So we want both the public and private endpoint access to our Kubernetes cluster. From here to the next page, information about observability. Uh, we don't want to configure this now because it includes, or it entails additional costs if you want your Kubernetes resources to be your metrics to be streamed to CloudWatch. So we don't want to activate any of these resources now, even monitoring on the control plane, not now. Of course, you can use different monitoring tools to scrape logs from your Kubernetes cluster and maybe ship them to Grafana dashboard. So Kubernetes works with add-ons. For example, you have the core DNS for DNS resolution. You have the node agent, monitoring node agent, which is deployed automatically. This wasn't an add-on before, it's recently added. You have the kubeproxy just for network configuration, VPC, CNI, and all of this. You might also want to add the EBS CSI driver if you want to mount EBS volumes to your Kubernetes cluster. So all of these are options that you might also want to consider adding. But for now, we go with these add-ons that have been selected for now. And there are some other add-ons. So you see the metric server also is an add-on which is deployed. If you don't know what the metric server is, it's simply a log scraper, also a default log scraper, which is deployed on your Kubernetes cluster. So you also have some add-ons from AWS Marketplace. These are just new features added to the AWS console. This we don't need for now. And we go to next. Here you're presented with all the versions of the add-ons we've selected. So you see the versions of the add-ons. What it will do is it will pick the default versions for all the add-ons and propose to you. So we stick to the default versions of all our add-ons. And then to the next page, you have the review of everything we've selected on our cluster. So we just review the network configuration, the add-ons, the monitoring, the version, and everything, and we click on Create Cluster. So you see the add-ons and everything is in creation state, and it takes about 10 to 15 minutes to have this cluster up and active. So it's in creation state. It takes quite a while to have this cluster go to active state. So we're going to pause the video for a second and we'll see how long it takes exactly to have the cluster up, and then we'll be back to continue with the node groups. So welcome back from the console. You can see it took approximately 10 minutes to get the cluster up and active. So now we have the EKS cluster running and active, but there is not much or anything we can do with this cluster. Reason being that we do not have nodes. Remember, a cluster has several components. A cluster has a control plane, which is the master node, like we commonly call it, and also has the worker nodes. And these worker nodes are where resources are actually deployed within your cluster. And these worker nodes are simply EC2 instances. Remember, if you missed out the difference between a managed and a self-managed Kubernetes cluster, EKS, Elastic Kubernetes Service, is a managed Kubernetes cluster, meaning the control plane and all its components are actually managed by EKS for you. And you just have to deploy your worker nodes, the number of nodes you want, and then you go ahead to deploy your resources on those nodes. So into our Kubernetes cluster, EKS Hilltop prod, you see if you come under compute, which is where we have our nodes, we don't have any nodes recorded here, and we don't have a node group as of yet. And you also have a Fargate profile. Now that's another thing, which is another way to have worker nodes, but we are going to focus on creating EC2 instances using the node group. So we are going to add a node group. So you go to node group and then you add a node group. So it prompts you to put the name of your node group. So the name of our node group, we're going to use the same name as our EKS cluster. So EKS Hilltop node group. So this will do. And it asks for a node IAM role. So what is this node IAM role? This node IAM role is simply the set of roles that allows the control plane to bind with the worker nodes you're creating. And that essentially makes these worker nodes join your Kubernetes cluster. So we're going to go to create IAM role or create recommended role here. So you click on create recommended role. As before, same thing with the control plane. It takes you to this console and it sees the service, AWS service, and it picks EC2 because now we're creating EC2 instances. And pre-selected, you see it has pre-selected 3 out of 1026 rows. So three permissions are already selected. So we're going to see what those 3 permissions are. So these are the 3 permissions. AWS EC2 container registry read-only policy. So it gives access for the nodes to access the ECR service, EKS CNI policy, and EKS worker node policy. So these policies allow your worker nodes or the node group to join the control plane, which is the EKS cluster. So we're going to call it EKS node group role. So we're going to call this our EKS node group role and create role. So our role has been created and you remember the name EKS node group role. And back to this previous tab, we're going to refresh and then we select the role we just created, EKS node group role. This is the role and I select. So for launch template simply means do you want to give specification of the type of EC2 instance that you want, the specification if you want um, instance of any particular type so that whenever, or you want to add some metadata or user data so that whenever there is an upgrade of your EC2 instance, you're scaling up or scaling out, it recreates EC2 instances containing those metadata. Now you have Kubernetes labels. We're not going to add labels for now, but when you watch the video on labels and selectors, you're going to see how useful having labels are in creating a Kubernetes cluster. Now, you also have Kubernetes taints. You should also watch the video on taints and tolerations. You're going to see what is a taint and what is a toleration and how useful it is on Kubernetes. And for tags, it's simply a way of identifying the resources that you create on Kubernetes. So we're going to leave that. Now it takes you to the node group configuration or the compute configuration. Here it's talking mostly about what type of Amazon machine image do you want to launch your instance with. It gives us the standard version of Amazon Linux 2 and also capacity type. Do you want spot instances or on-demand instances? There's a difference. You can check up what is the difference between a spot instance and an on-demand instance. And also the instance type. Here you can filter through so many instance types to see which of the instance type is favorable for you. But T3 micro, so you can go for T3 small, T3 micro. I mean, any of these will do for the Kubernetes cluster. So for the purpose of this course, we are going to start with T3 medium, which gives us simply two CPUs and 4 GB of memory. Disk size, we can leave it at 20 for demo purposes. And now, more importantly, node group scaling configuration. Now, there are three boxes you need to check, which is the desired, the minimum, and the maximum. So what is the desired? The desired simply means at any given point in time, how many nodes do you want running? Or upon creation, how many worker nodes do you want? So we desire to have two. What is minimum? Minimum simply says if something happens and your nodes are failing or scaling down, the minimum number of nodes you should have is two. So for best practices, you want to have your desired a little above your minimum. You can keep both at the same, but it doesn't really matter. Minimum says no matter what is happening, always have two running. So this also include a cluster upgrade. If you're doing cluster upgrade, how many should be the minimum running number of instances? So you have to consider that. Then what is maximum? Maximum simply means if your nodes are scaling up, then maybe some processes are happening and much CPU is being consumed and your node is configured on auto scale on an auto scaling group, then what is the maximum number of nodes it should scale to? So it is better to have the maximum number of nodes a little above the desired number of nodes. Okay, so we're saying at any given point in time, no matter what is happening and our cluster is scaling, the maximum number of nodes that can be created during a scaling scale out action is 5. But at the time of creation, we are going to have 3 nodes. Or we can reduce this to 1 and then we reduce this to 2. So our minimum is 2 and our desired is minimum is 1, desired is 2. Now, node group update configuration. Now, remember when we were creating the cluster, you notice that we had the cluster version. So when you're updating the cluster version, you likely have to upgrade the node group version as well. And when you're doing that upgrade, it simply means that the nodes are being recreated. So what is the order or what is the configuration of recreation? It simply means that how many number of nodes should be updated at a given time. So, so we are saying since we are creating two nodes, we mean one should be updated before another is being updated. So if you put two, you're simply saying two of the nodes are going to be updated at the same time. And this is not advisable because it means your resources will be unaccessible for some time before the nodes are in ready state for those resources to be redeployed automatically on it. So when we put one, it simply means that Kubernetes is going to redeploy all your pods on one node while it upgrades the node to get the other node upgraded. So that's simply what is going to happen. So we're going to go to this default update strategy. So we're going to be upgrading one node at a time. Node auto repair configuration. If there is a problem or if some failures are automatically dictated on your node, can these nodes be repaired automatically? So we can skip this for now. And we have the subnets. So you must make sure that the same subnets that were selected when creating the cluster or the EKS cluster should also be selected when creating the node group. This allows your worker nodes and your Kubernetes control plane to be on the same network. Is very important. If you miss selecting one of these, it means some of your nodes that are going to be created are not going to be part of your cluster. So you make sure that the subnets that you select are the same subnets that were selected when creating the control plane. So we review all the configuration that is done, and then we go to create node group. EKS cluster node group is now being created. The process takes several minutes. So again, this will take a couple of minutes, probably 10 as well, but we're going to just hold on the video and come back when it's in active state. So you see it's in creating state now. We're going to come back when our cluster is in active state. Okay, we see our node group is active. This took about 3-4 minutes for the node group to become active. So we back to EKS and clusters. This is our cluster which is active and is running version 1.39. And we go to the node group, compute. You look at our node group, you see our two nodes are already created and they are in active state. Our node group is active and we have two EC2 instances of instance type T3 medium, and they were up 2 minutes ago. And you have some insight into your cluster. EKS add-on version compatibility. So you have an add-on which is not compatible. So this is the updating EKS add-ons. So you can come to the add-ons of your cluster and also upgrade those add-ons. So these are the add-ons. You can metric server degraded. So it says we need to upgrade the version of the metric server. All of these add-ons are degraded. So the versions need to be upgraded as well. But this is no problem. So we have the EKS cluster up and running. And if you want to learn how to connect to your EKS cluster, please watch the next video, how to connect to your EKS cluster and how to deploy resources. Please like this channel, comment, and if you want more videos are loading up. And this is Chafa Sani with Hilltop Consultancy on how to create a Kubernetes cluster with EKS. So in the next video, we're going to be connecting to our EKS cluster. So thanks for watching.